Hi, good morning, and today is the 29th of July, 2021. I realise I put the 28th of July, but that's because I put the slides yesterday. But today's the 29th of July 2021, and every Thursday at 8 a.m. We do a webinar specifically for our ZP developer members, ZP Developer Zone members. We have the Academy, which I talk about. We have the developer zone itself, we list jobs, or we help facilitate jobs for our members, we do collaborations, and we have these webinars, and I will just go through. So the live stream that we do every Thursday at 8 a.m. is driven by questions that come to us via the Academy. So there's a forum on our, sorry, not on the Academy, via the Developer Zone. There's a forum on the ZP Developer Zone that people can list questions and then we answer them. So there's a link to that. So this week we had an inquiry from one of our ZP Developer Zone members. And he says, I'm trying to functionalize multiple SPEs with nanomaterials. So he's trying to functionalize multiple screen printed electrodes, as he says, with nanomaterials. He talks about PBT. The problem I'm facing is that he's not getting repeatable results. He's trying CV, differential pulse voltammetry, EIS, electrochemical impedance spectroscopy. Now what was really good was, I was really pleased or happy, was that Ali and Aftab responded to him. And Ali put on the forum, you need to check those surfaces. You need to make sure that they're cleaned or well polished. He said that you're better off doing some surface examination using redox probes like ferrocene. I mean, I would say as well, ferrocene is good. You can also use ferricyanide, but I mean, it is a good point. If you're not, a lot of screen printed electrodes. Now, I don't know if the inquirer is actually using ZP screen printed electrodes. If he is, then I have to apologise, and we'll really, we'll take a look at the data and, help him understand. If he's not, then I would definitely suggest that if you're using screen printed electrodes, you've got to really check them, because they can come in really variable. So please, Ali says, look, you really have to check those surfaces, and you probably have to check them with a redox probe like ferrocene. I mean, we check our surfaces quite a bit. And I would suggest ferricyanide. I might suggest ferricyanide a little bit more, because ferrocene might sometimes it could potentially stick to the electrode. But yeah, ferrocene or ferricyanide. So I'm just saying hi to some of the guys who have joined online. And then I'll go on with the presentation a bit more. Now Aftab responded and said, look, if you want repeatability, you're gonna have to control all your conditions. And so when I read Aftab's response, he said you have to control the the temperature, the conditions of what you're doing. You probably have to control the surface, which was actually in line with what Ali had said. You really have to make sure that surface is repeatable, and you also have to make sure that your solutions are repeatable. So I'm pretty sure that the guy is, the inquirer, the ZP Developer Zone member, he's check your surface, check it's clean, check it, as Ali says, with ferrocene, or maybe 1 millimolar ferricyanide. Aftab is saying, again, check your surfaces. Make sure your solutions are the same. I'm pretty sure you must be doing that the same. Temperature's an interesting one, because in a lot of labs, if the labs are not air conditioned, the temperature's not necessarily that well controlled, and that is a parameter that you have to control. So obviously the first thing to say is screen printed electrodes can sometimes there is a few vendors out there that ship screen printed electrodes, but really they're not so repeatable. So the underlying screen printed electrode is not repeatable. So people build biosensors on top of these irreproducible screen printed electrodes, and then they have an irreproducible biosensor. Cool. What I'm going to say to you, look, is Hasim has seen this video before, Aftab has seen this slide before, Ali's seen this before, Philippe has seen this before, but you know, look, these gold electrodes, this is how good we can make an EIS immunosensor on top of a Z-piece gold electrode. So you can make repeatable sensors on top of gold electrodes. Now, you know, your legitimate question could be how. I will yeah, sorry, so what I will do is say, look, you know, there's some good gold electrodes out there you can use, but I think this inquiry is actually using carbon. So if you're using carbon, I've given these slides before as well, but these slides are saying there's a good paper out there. You should be able to get this paper free on ResearchGate. What I will say is, have a read of that paper. Now, if you're using ZP electrodes, the inquirer, then I'm sorry that, you know, they're not working the way you want, and we'll take a look at it. If you're not, you should be able to get some pretty reproducible biosensors. That's what, you know, at ZP we are able to do that. I've told the guys before, you know, it takes a minimum of 111 hours to make something that's vaguely working, and now we do it with a team that's been doing it for quite some time. So, you know, we use a team to often do biosensor development. It's not necessarily one person on their own. You know, the good thing about having a team doing it is, you know, essentially we can brainstorm and troubleshoot whilst we're, you know, together. So what I would say is this. Functionalizing the electrode. So Ali and Aftab were kind of saying, look, check your surface, and Ali definitely said, you know, look, you know, you have to kind of check the surface at every stage. So what we're doing is we're starting off on this kind of work with something like 60 screen printed electrodes. We test them by cyclovoltammetry, we rinse them, we put the coupling material on, and if the coupling material is something that we refer to in the paper, we leave it there for 4 hours at 4 degrees. So I suppose it tells you a few things there. First of all, we've checked the electrodes. We made sure that they, you know, we think they're good. We've rinsed the electrodes, so we've got rid of all that ferricyanide. We've put the coupling agent on there, and we've left it on there for at 4 degrees for 4 hours. So we've controlled the time and we've controlled the temperature. Then we test them again to make sure that the coupling reagent has essentially binded. And then we test them to make sure that the binding took place. Then we rinse them and we add the antibody and we test them again. So every time we're testing them by cyclovoltammetry, we're making sure that we're altering the surface, and we should see a change in the cyclovoltammetry. So we start off with something like 60 electrodes. We test them by cyclovoltammetry, make sure they're good. We put the coupling agent on. We test a few of them to make sure that the coupling agent went on the surface. We take them through, and then we put the antibody on them. We test them again, and then we actually put the blocking agent on the BSA, the BSA is obviously the sort of final blocking agent to stop non-specific binding, and then we test them again. So every time we do a test, we're probably sacrificing like 3 electrodes. So, you know, we started off with 60 sensors. We took it down to 57, took it down to 54, took it down to 51. And now we're actually adding the antigens. And now, you know, this is when we actually start doing the test itself. And we test those. We put on some higher concentration of antigen and we test those. We put some higher concentration of antigen, we test those. Put some higher concentration of antigen, we test those. Now, so we have quite a formulaic, let's say, workflow, you know, that we use, and it, you know, it seems to work. But, you know, essentially we started off with quite a number of electrodes. We tested them. We did the coupling agent. We tested them again. We did the antibody. We tested them again. We put the blocking agent on, we test them again. So we're testing them at every stage to make sure that every stage is working. I mean, you should see a fairly significant change in the cyclovoltammetry every time. And then, then we actually do let's say the actual testing itself by putting the antigens on. So let me just, and then we actually do the data analysis itself, which we do by EIS. Now it's probably worth saying that we sometimes have to use quite complicated maths to do this. So, we make an equivalent circuit. So we don't use R1 because R1 just tells us about the electrolyte. But we often are interested in C1, but the antigen in our experience is often associated with Q1, R3, and this angle here. So we end up in our study sometimes actually using all of these components that we combine. So we say that the signal is proportional to each of those components that we weight. So we do have quite a strong data sciences team that works on this. But then we are able to get quite good signal versus concentration. So let me sort of back up a little bit and say the whole idea of the ZP Developer Zone is to answer questions of the forum. It's great because Ali and Aftab have both, said to the guy, they both said check your surfaces, and Ali and Aftab said check your overall conditions, which I agree with. I'm also kind of saying that screen printed electrodes fundamentally you can make repeatable biosensors on them. I think we are able to display that kind of data quite routinely at Zimmer and Peacock. And also, if you kind of follow the paper that I suggested for the carbon electrode, then I'm pretty sure that you will then be able to sort of make some electrodes as well. So let me just go on a little bit. The thing is, if you're not, the reason I do suggest you are using our electrodes is we do something that the guys know about. It's called wafer mapping. Before we ship any electrodes to anyone, we make sure that we test them all. So we've tested them by ferricyanide ourselves using cyclovoltammetry, and we make sure that the batch, all the electrodes in the batch are actually good. So we've got about 50 electrodes in this data set here. So we've done at least 50 tests. We often do 50 tests 3 times. We often test 150 electrodes from a batch of electrodes before we'll actually bring them into our stock and say that they're good. So it's that kind of diligence that means that when we ship the electrodes, then you don't have an irreproducible electrode. What is the biggest problem, or one of the biggest problems in biosensor academic research? It's the irreproducibility of the screen printed electrodes. How do you solve the problem? As a manufacturer, we solve it by actually checking the electrodes before we ship them. So that's how we're solving it. Now, what I suggest is that, whenever you've got the carbon electrode, the gold electrodes, don't flood the electrodes with your reagents. I suggest that you just put 3 dots along the electrode like this, and then just spread it with a pipette tip and cover it that way. So if you're having a problem with irreproducibility, then I would suggest that you need to get that deposition pretty reproducible. So do it, please do it the way I've just suggested, that you don't spread it over everything. 3 dots, and then just drag the pipette tip and merge the 3 dots that way. We obviously use a robot, so that really helps us with our reproducibility. And I know that you won't have a robot, but why do you sometimes not get reproducibility? The underlying screen printed electrode's a problem. One of the other problems then is reproducibility of deposition. To solve the reproducibility of deposition, we use robots. I mean, that's that simple. It's not easy. I know they're expensive, but that's what we need. It's also probably worth saying that when we're sort of drying our materials, we don't just necessarily just dry them at room temperature. We might actually put a slight vacuum, but what this tells you is we're really controlling the conditions. If you have a solution that, if you, let's say you did a drop casting onto an electrode, if that drop casting dries in 30 seconds, that will give you one type of film. If it dries in 3 minutes, that's a very different type of film. So you do have to control the deposition and the drying of these materials that you've potentially drop cast on the electrodes. Now, we don't make one electrode at a time. You know, in order to get the kind of numbers that are necessary, we are testing, 12 electrodes at a time. So you need to be making fairly significant numbers of sensors in order to kind of learn the manufacturing and to eventually get to reproducibility. And when we say a controlled environment, this is Nee, one of our engineers. This is Andre. This is Petter. You can see the kind of conditions that they're working in. So if you can't get reproducibility, Aftab in his response was kind of saying, well, you need to control temperature and the solution. You need to control the environment, and it's not done very much in university laboratories. But this is how we do it. The feet are covered up. The person's in a complete gown. Their hands are covered up. If he's actually working on a sensor, he's got a face mask on. This is how much precaution we take to make sure that we don't drop dust or skin or anything onto the sensors. So that's how we can achieve reproducibility. And here they all are, getting trained up. And I think one of the big secrets for reproducibility is we have what's called a quality system. So it means that we will write down exactly what we're going to do, and we'll do it at the same time every time. So there's a whole team. There'll be a different team that makes up solutions, a team that tests solutions, a team that does a deposition, a team that does testing. So don't beat yourself up too much if you find it struggling sometimes to make reproducible sensors. You can see the kind of money that has to go into the environmental conditions to really make reproducible biosensors. So I want people to be a little bit gentler with themselves sometimes. I just want to turn to something that last week we had a conversation about a low-cost board for ion selective electrodes. So we had an inquiry last week that said, look, I want to test one of your nitrate sensors, and I said, all right, well, we've got a new set of electronics. I like it because it's super low cost. It's €250 each, and on our website we put a lot of information regarding how to make a connection. So I just wanted to show you a video that we put up just this week. So if you're looking for a low cost potentiostat, I think the best ones on the market are the Anna Pot from ZP. We also sell the Sensit Smart from PalmSense. So this is not a potentiostat, but what this is a low cost electronics that allows you to read ion selective electrodes. So this will work well with sodium sensors and pH sensors and nitrate sensors and potassium sensors and calcium sensors. So this will work well with ion selective electrodes. And we didn't have a video last week, but we've made a video since then. So in the video we talked through the board. In the video here, the engineers put a ZP pH sensor into the board. She's connecting to it using a USB cable. So she's just checking what's called device manager, making sure she's connected. And then she's running a terminal program. So she sets up the terminal program, and the terminal program then will just bring data across from the board, which is what it does. And then she does a little test where she puts on pH 4, I think initially maybe. So she puts that on, and then in a bit she'll take off the pH. So she's looking at the raw data, essentially streaming down. I think and let's just have a look. And then she changes the solution and puts on a different pH. I'm not sure. It might be pH 10. I think if I look very carefully. And then she puts that onto the sensor, which she's doing here, and then the value changes because essentially a pH sensor is a form of ion selective electrode, and so now by changing the solution, the voltage has changed. So we had an inquiry. I suggested this set of electronics because I like the price basically, but I'm not trying to say, look, this is a full function potentiostat. It's not. It's a low cost set of electronics for ISEs. But what was nice was Ali took a look at the video. Ali's one of our members, and I know he's put together a Excel spreadsheet. So Ali runs Technando in India, so he represents us in India. But he put together a spreadsheet so that it's actually the Excel file will connect, essentially will connect to our electronics and bring the data straight into Excel. So I thought that was kind of neat. So I just wanted to highlight that. So let me just do a quick summary. That's interesting. Hopefully you guys can see the video okay.
Connect.
Yeah. So let me just do a quick summary. The summary is this. If you are struggling to get reproducibility, making a biosensor on screen printed electrode, I'm very biased, so I'm going to suggest if you're not using ZP screen printed electrodes, please use them, but I am biased. After that then, you kind of have to have a very methodical approach where you take your electrodes, you add your linking molecule, you check them by cyclophotometry to make sure the linking molecule went on. You then add the antibody, you check it by cyclophotometry to make sure that that went on. You then add the blocking material, you check them by cyclophotometry, make sure that went on, and then you're ready to do your experiment. And you have to be quite methodical about it. And you saw, you know, you saw the clean room environment that we're doing it in. You know, so we're checking our screen printed electrodes before we ship them to the client, so we got good confidence in our screen printed electrodes.
Did I misspell it? Yeah.
So we check the electrodes by cyclophotometry before we ship them. We check them at every stage. We do use EIS an awful lot, but I would just, you know, if you're getting really stuck and you're a ZP Developer Zone member, sort of post some data or something on the forum, and we'll take a look at it and see if we can sort of help you out a bit, because that's the whole point of the forum. And finally, thank you very much to Aftab for, as I say, he's made a new spreadsheet which apparently will connect to our electronics, and so you can do an ion selective electrode, stick it in those low cost electronics, and then you can just, the data will just be opened straight up in Excel. So that sounded pretty cool. So I'm going to wrap up today. I just want to say that what's happening this week is there's the Biosensors Congress 2021. So I think from a research perspective and an academic perspective, this is probably the world's biggest conference on biosensors. It's unfortunately online this year. But I just want to say I'll be, there's a session 3I this afternoon, which is on commercializing and screen printed electrodes, and I'll be chairing that session, so I have to make sure I'm prepared for that. So slightly shorter this week, but thanks to Ali and Aftab and Philippe. It's good to see you guys again. We had an inquiry called Santosh, Santosh, I saw that you've just sent me an inquiry via the website. I'll take a look at that now. But yeah, thanks very much, guys. I appreciate you all coming this week, and any questions, anything, put it on the forum, and you know, we'll be happy to speak to you guys soon. All right, cheers, and thanks Aftab for making that spreadsheet. Looks cool.